Hello, welcome to Apply Database 1. In the last few sessions, we created a database that did not exist through interviews, through forms, or any information given by the small business or an organization. In most cases, the database will exist, but we need to manipulate and make changes. So if you were not assigned to create, develop, design, and create the database, you will be assigned to manipulate the database. It's already there, and you have the database, but you need to manipulate, make changes, update the database, or create queries to retrieve some information from the existing database. So to do that, we are going to use SQL or SQL Database Manipulation Language, DML language. The commands used in the manipulation process differ from the one used during the initial creation of the database. In this session, we will go over some of the SQL statements that can be used to manipulate the database. If you remember, we talked about that before, and we said that part of data manipulation is the select, insert, update, delete. And the fundamental framework for SQL query statement is the SQL Select Statement. We use the Select Statement to select the required columns from a certain table under specific conditions. Once you are done writing the code, you end your SQL statement with a semicolon. So we have the Select Statement from which will give you the name and where is the condition that we use, and then we end up with a semicolon. Let's go back to Oracle Live SQL and the query, and we are going to create a query for the artist table that we created before. And again, we did that before. Let's do it again and see how we can just display or use the select statement to display part of the database, not the whole database. So this is my Oracle Live SQL, and those are the previous session that we did before. Instead of entering the information again and doing it again, all what you need to do is just to rerun, and once you rerun the code, it will give you the confirmation that the schema being executed and the information being inserted, everything is there. So now we have a new session, and with that new session I can continue with my work. So what I did, I just redid the session that we did before for the artist, the transaction table, the customer table, and the work table, all the information that we did before. Now remember what we did last time. We select and we displayed some information from the work table. We also selected the name and nationality, so we can actually run the code and we are going to select from artist table, and we are going to select name, comma, nationality, and then we can order by name. So we will run, and you can see that we have the columns that we selected. So this is type of manipulation. The select statement here has been used to manipulate the data and display part of it, not all of it. So you can display any part of the database that you have. I don't have actually to be restricted with the sequence or the order of tables in the table itself, in order of columns in the table itself. For example, here we said name, nationality, because maybe this is the order in the table, but that's not a must. So actually I can do nationality first and then name and run, and now it's giving me nationality first and then name. So you can reorder the way that you want. You can change the order of the columns to display it the way that you want. So the display doesn't have anything to do with the order within the table itself. We can also select or add to select distinct nationality name from artist, and using the word distinct will show distinct data by either taking repeated names or rearranging data based on the columns that was selected to be distinct. So now you can see that the data being reordered in a way that it's unique every time. So once it's done with repeating the information, started a new information and looked at, do we have German again, do we have Russian again, do we have French again? So German, no German, then it skipped that, and then French started with the French. So it did reorder by distinct, by uniqueness, and then went back to find others. So it will go like German, French, Russian, German, French, Russian, and so on. And this is how the data being rearranged. How about if I want to display all the columns? I don't know the names here. I know that there was nationality and there was name within the artist table. What if I don't know the names of these columns? What can I do? At this point, I can just put the asterisk, and this is a wildcard that can be used to display data. So during the exploration of the database, you can use the select statement and list all names to display it, or you can use the asterisk to display the columns. So if you run, it will display all columns for you using the asterisk. So the asterisk is the wildcard that you can use to display all columns if you don't know the names. So instead of saying select artist ID, name, nationality, birth date, deceased date from artist, you can just put the asterisk, and that will display all columns for you. We can also sort the results where we can order by, and then we can have two in the order by. We can have two columns instead of one column. So I can select. I will use the wildcard from the work table, and I will order by. I will have work ID and artist ID. And then run. So what it did, it went to the work ID first, and it ranked 416, 516, 523, 552, 585. So it's ordering by the work ID, and then it goes to the artist ID and start the ordering from there. So from 516 we have only one, that's why it's 523. If we have more than one, then it will start reordering based on the artist ID number 5. So let's assume that we have more than one work ID for the same artist. Then you can see the numbers here will be rearranged based on that. But since we have one work here for every artist, it went first with the work ID and then with the artist ID. We can also specify that we want that to be descending or ascending. So we can change this to descending and change the artist ID to ascending and then run. And you can see that this has been changed. Instead of going from the lowest to the highest, it's going from the highest to the lowest, and that's why also this one has changed too. You can use the select statement with where condition to display specific records. For example, in the work titled, we can check or we can find the work titled night bird for artist ID number 4, and the results will be no data found. Let's see, work, and then I will add where title equal night bird and artist ID equal four. If you run that, it's going to tell you no data found. Why? Since the selected artist ID with ID number 4 did not create the work night bird, so that kind of combination where we say where this and this, both conditions has to be satisfied to be able to display. But we know that number 4, artist number 4, did not produce, did not create this work. Now if you change this to 3 and say run, it's going to give you the information, which means that this work has been created by number 3, Nightbird by artist number 3. That's why it displayed that. So basically we are displaying a specific record from the database, just one specific record, and this is what we need when we do any audit or any query. We are searching for one record of information. This is what we are looking for. We are looking to eliminate all the other information and concentrate on that record only, and that's what we did here. We can use OR. So at that point, if we return it back to if we go back to 4 and put 4, but instead of and, we can put or. Now we have to specify one condition only, not both. So it's either or that information. For that, when you run, now it's displaying both because we have to specify one of them. night bird, this is the night bird, and then artist number 4, this is artist number 4. So since it's either or, it displayed for me both results, both conditions. Okay, and that's the difference between the and the or within the where statement. We can also specify within the condition of where and use where the column in. So for example, I will go back to artist table, and then I need the condition to be nationality equal, instead of equal, in, and I want the nationality to be either German or French. And run. Now notice that it displays the record for German and French, but did not display the last record, which was for nationality Russian. That means that we eliminated based on the condition that we have here with where and in, and we have a domain that we need to select from. So if we say that where nationality in British, and we deleted that and say run, no data found, because none of the information that we have has a British nationality. And again, that will confirm for me, okay, I don't have an artist from a British origin, but I have from French, German, and Russian origin. So that will confirm the information for me when I do the select or the query that I need. We can also say not in, and then I can say German, and French. So I'm saying give me any other nationality than those two nationalities. I don't know what other nationalities exist in the database, so I'm saying okay, exclude those and show me what's left. So it will exclude those nationalities, the German and French, and it will display the only record that is different, which is Russian in this case, and that will be my record that applies to these conditions. We can also use between, where and between, which will give me a range of information. So we can say give me a range for the artist birth date, and the condition will be between (1860) and 1870. So the 60s and the 70s. 1870. and then run. And you can see that this birth date is 1866, which is between this range, or within this range, and 1869. So it did display for me the range of data with birth date within those 10 years. We can use the where and use the range, but with a math expression. So instead of between, we can say that birth date is greater or equal to 1860, and birth date is less and equal to 1870. And then run, and it will give me the same information. So whether you use it between or you use the math expression, the greater than, less than, that will be the same. We can use also other wildcards within SQL. So we can use name like. So with where and like, the like wildcard has lots of options. For example, if you don't know the last name, then you can put the first name, and instead of the last name, the wildcard in this case will be the percentage. And then close the statement and run. And it gave me the only person with first name Henry, and this was the last name. So I didn't know the last name, I just added the percentage, and it gave me the record that I'm looking for. So that's one of the wildcards. Another wildcard will be, looking at the like with wildcards that can be used to display a statement. I don't know what's before what and what's after. So we can use the table work and use description like, and now the description, I don't know what's in the description, but I would like to see the word style in that description. Work with word style as a description. Style. I don't know what's before and what's after that word. For that, I just use the wildcards, which is the percentage, that will assist me in just getting any record that has the word style in the description. And then run, and we can see that the description here, it says the serialist style or realist style. So I got those two kinds of descriptions or records for the description that has the word style in. Continuing with the where and like, and using other wildcard, we can use artist and then deceased date, like I can use the percentage before, and then I will use the year 19, but I don't know which year after that, 1900s, but when in the 1900s I don't know. So for that I will replace it with underscore, each character with underscore. So I will put 1, 2 underscores, 2 underscores to continue or to complete the year for me, and then run. When you have an error in the spelling, it will give you invalid identifier for this column. So I corrected that. Deceased date, like, so this is the spelling in my column, and I will run, and I will get the dates, which is 1944, 40, 54, and 85. So those are the people who were or who passed away in the 1900s. Now notice that we have 4 records, and the first 2 were in the 1940s, and then 1950s, the third record, and the last record in 1985. So if I add, for example, 8 only, who died in the 1980s from those artists, and run. Now remember that each underscore is character. So I forgot to delete 1 underscore. I will delete 1 underscore and keep only 1, and then run. And now it's giving me who passed away in the 1980s. Only 1 record, 1 person who passed away in the 1980s, and that's Marc Chagall, the French artist, in 1985. Remember in the last session I told you go ahead and insert customer information. If you didn't have the chance to do that, then we'll do that right now, because insert is one of the codes, or the SQL codes that are used, or that's used for data manipulation. If we would like to insert another record, then we can use that kind of command or statement. So we run, and now we have 4 rows inserted in that table. We can do the same for the transaction table, and in this case, what I would like to show you, that the format for the date acquired, is always, the format in Oracle is the date, the month, and the month in words. So you can see here we put NOV, November, for the November month, and Jan for January, and for the year we have 4 digits. So this is the format for the date. So if you use date in your SQL code, this is the format that you need to use to enter the information or to insert the information in that table. So we execute the code and we have 4 rows that's been inserted into the transaction table. We can use some kind of calculation in our code using the data manipulation. To perform some calculation, we are going to use the transaction table and get the sum of the sale price. And you have the sale for all artist works that we did or that we sold was 225,500. So this was the total sale, and we got that from the table information. So we can do calculation. We can use built-in functions to do calculation for or from the tables. I can use also other built-in function such as average, minimum, and maximum, just to arrange them in a way from the transaction table. And we run, and you can see that it gave me the average sale, the minimum sale, and the maximum sale price. So the sale price, the minimum was 27,000 for one of the artworks. The maximum was 98,000. So the average was 56,375. Again, those are built-in function within the code that we can utilize and we can use to calculate or to find certain values. Another built-in function is counting the number of rows. I'm looking at huge amount of data. There is a database that was given to us. It's huge, and we would like to know how many rows do I have. How do we do that? All what we need to do is to use the wildcard or the function, built-in function, which is count. So count is a built-in function, and we are using the wildcard, the asterisk, to count for me the number of rows. And we need to save it somewhere. So we save it as number of rows or num rows, and we are talking about the transaction table. So we run, and it's giving me that we have the number of rows in that table 4. If you have thousands or 100,000 or more than that in number of rows, so that will be an easy way to know how many rows, how many records you have in the database. We can also count, but using the distinct function, which will count based on the value of the data points that you specified. In this case, we are going to use it with nationality. So let's count, and you can see although we have 4 records, but we have 3 nationality. And again, this confirms that, with using the word distinct will count the number of rows or records based on the column that I'm using, in this case nationality. We can use a statement to calculate. In our case, I don't have quantity, but if I have quantity, if I can add quantity to the transaction table and say that we have 5 sold from this artwork or 3 sold or something, then you can calculate the quantity multiplied by the price to find the extended price for certain work or for a certain customer actually. And that's how you create the invoice. But we don't have the quantity here, so I will leave that to you. If you would like to add the quantity, that will be to you. We can use a query within a query. In this case, the second select statement is considered as a sub-query. Let me show you how we can do that. So in this case, you can see the select sum price as total per state, and I need to find the number of sales based on the state. For that, I'm using where statement, the condition here, but when I give the range, instead of giving the states, actually I'm taking the information from the customer table and putting another condition. So this one now, the select statement here within, is called a sub-query. So this is the main query and this is a sub-query within the main query. When I run that, then it's giving me that total sale per Washington state is 167,500. So this is the total sales per that state. And I can specify, I can change the state. Every time I change it, I will get a new value. We can use joins to retrieve information from any number of nested table. For the subquery, we can retrieve information from the top table only. What we did here, we just got the information from the top table, which is the transaction table. Those are the values. But if we need to get information from all tables, all nested tables together, then we use the join or the joins command. So we have the select statement, and we are looking at last name and sale price as sales customer, and we have two tables that I'm using, which is from customer transaction, customer and transaction, and we have the where customer.customer ID is equal to transaction.customer ID to confirm that I'm using the same customer ID from both tables, and we can order it by and say descending. So what I did, I created a join between two tables and got information from two tables. The last name from customer table and sales per customer from the transaction table. We did last time also adding and to add a column, what we did before, we added the email. If we would like to add the email for the artist, in most cases this will not assist us because the artist already passed away. But if you would like to add that, then you can use the alter statement to alter the table and add whatever you want. You can add a column, you can add constraint, you can drop a column or drop a constraint. So, and we can see that table being altered, and to make sure we can go back to that table and make sure that the email has been added to it. So you can go to schema and look at the artist table, and you can see the email being added exactly as you specified. It's null, it can be null with variable character 2 and length of 100. again, since the email doesn't make sense here, and we found that all these artists are deceased, so there's no use of using the email. Why do we need the email? Then I can drop that column and drop and table being altered again, and we deleted the column that we just added there. And again, this operation we did it before. I'm just reminding you that those the alter of adding and dropping is part of the DML data manipulation language. And we can drop a work or a table. Now if you try to drop the work table, it will not allow you. Why? Because the work table is not a standalone table, and it's connected to the artist and it's connected to the customer. For that, it will not allow you to remove the table. But we use the drop table, so the statement that can be used is drop table work, and it should drop that table for us if there are no constraints, there is nothing. If I try to do it now, it will give me an error message here because it's connected, it's relational database, so it cannot be altered or deleted. We can use update, and I will use the artist to change the nationality for number 5 to Canadian, and then run. And you can see that one row has been updated. So if you go to the schema, and or actually instead of the schema we can use the select. I will go to select and the wildcard asterisk from artist and run, and you can see that number 5, artist number 5 has been changed from French to Canadian, and now I have 4 different nationalities. So we changed the 5th one from French to Canadian, and that's the update that we did. We discovered that they have different nationality, so I changed that. And then I can delete the record. I can delete from artist. Remember, if I did not use the condition where artist ID equal 5, then at that point it will delete the all the records that you have in the artist. So be careful when you use delete from. If you stopped here after the word artist, then that will delete all the records from there. So make sure to use a condition, and that will delete only the specified record. That will be all for this session. Again, we talked about the data manipulation. There are lots of things to learn about that, so try to practice all that and make sure that you can get the different commands and statements that will be used to manipulate the database. That will be all. Thank you and have a great day.